Okay, good morning or good afternoon, everyone. Welcome to APNIC eLearning web class. Today is Wednesday, the 15th of April in 2015. It's actually already 3 o'clock in the afternoon from Brisbane in Australia, where I'm broadcasting this class. Now, this is already the third session of all our web classes for today, and the topic that we are going to discuss is an introduction to autonomous system numbers. So I guess coming into the class, you've already heard of an ASN or an AS number, and you want to expand your knowledge on this topic. Now, before we go on to the details of what we're going to cover, I'd like to also first introduce myself. My name is Cheryl Hermoso. I work as a training officer for APNIC, and as part of the APNIC's training team, we do deliver workshops either face-to-face or online, such as this, to the members of the internet community on topics that are related, of course, to internet technologies. Some of the topics I have listed down there that we cover are network security, IPv6, DNS and DNSSEC, internet resource management, routing, and BGP. Now, this particular session, which is about autonomous system number, would somehow fall into both internet resource management and routing. So a bit of understanding of both would be good coming into here, but otherwise, if you don't understand some of the topics that I'm discussing, you are always free to ask questions. Now, just a brief reminder that the class runs for 1 hour, and at the end, I will be asking you to fill in a very short survey. The link will be listed down. I'm going to type it into the chat later on. If you can please fill that in for me, that will be good. Okay, now for the content or the overview of the topics for the entire 1 hour session, first of all, we will of course try to understand what is an autonomous system number. What exactly is an ASN? Obviously, it is a number that uniquely identifies something, and that is the autonomous system number. So what is an AS, an autonomous system? Let's try to define that. And in this context, how do we use an autonomous system number when it comes to routing? Why do we need it? And when do we need it? What do we use it for? Aside from that, we will also be looking at the process involved when requesting your AS number. Now you know why you would need it. In case that you would, then how do you go about the process of requesting it? We'll look at some examples such as how do you represent a routing policy, how does it look like in the WHOIS database, and how do you use the AS number to show your different peering partners. Now we will look at two types of AS number and how do we represent them. We'll look at 16-bit and 32-bit ASN and understand the difference between them and how they interoperate with each other. So those are the topics that we are going to cover. Hopefully we will have enough time to cover everything. And if you have anything further than this that you want to maybe ask, again, feel free. You will just have to write your questions in the chat panel. Okay, let's start with the very basic question. What is an ASN? If you hear someone talking about it, maybe your peers, your colleagues talk about ASN, it stands for an autonomous system number. It's a number, it's a globally unique identifier that identifies a network that is on the internet. Now, this network that we are referring to is what we call as an AS or an autonomous system. So basically, an AS number is what we use as a unique identifier of an autonomous system. So we allocate that to each autonomous system. And when do we usually see it? It is normally used with BGP. So it's essentially used when we're configuring BGP, when we need to send, receive, announcer prefixes to the global routing table, and basically to exchange routing information between us and our neighbors. So it's used in the exchange of exterior routing information between us and different autonomous systems. Now, to further understand this, we also need to know what is an autonomous system. To clearly identify an AS, so that's a short term for an autonomous system, the major characteristic of this is that they have the same routing policy. So you can think of an AS as a network, right? It's just a simple network. But when we talk about network, it can refer to a lot of things. It can be a local network, it can be a WAN. So the distinction between your network and other network is kind of ambiguous. With an AS, you're clearly defining by having the same routing policy that this routers here, this networking equipment, all belong to the same AS. A routing policy defines exchanges of routing information between different autonomous systems. What types of traffic are allowed coming from this peer? What kind of routing information am I sending through him? Is it only the ones that I'm originating? Or am I also forwarding or announcing other people's prefixes? Things like that. How data traffic will flow into the AS and how data traffic flows out of the AS is also defined by your own policy. This means that an ASN enables an AS to exchange exterior routing information between its neighboring AS. So I hope you understand it when I talk about autonomous system. We will take a closer look into this and give you some examples, but I hope at this point, to be able for us to understand what is an ASN, we clearly have to identify what is an AS. And an AS is defined by two things. One is it is defined by a single routing policy, and the second is it's usually under a single ownership, trust, or administrative control. Okay, next one, let's have a look at how autonomous systems work. So in this example, you show different networks or different autonomous systems defined or represented by a cloud. You have their AS1 all the way to AS7. Now, each of them have different connections. They might have direct connections, let's say from AS1, you're directly connected to AS2. There's a direct connection between AS1 and AS5. And then same with all the other autonomous systems. For your traffic to reach another network, it will have to go through or pass through different networks. In this case, for example, if you have, let's say, you're sending information, you're sending packets from AS4 all the way to AS1, you should have an idea of how to send your packets going there. So the boxes that you see next to the AS representations are prefixes. So these are routing information that are on these routers routing table. So in this case for AS1, it has connection to router 2 or AS2 here, so and also AS5. And then for the rest of the traffic, it is defaulting to its one of its links. Maybe it's going to AS2, maybe it's going to AS5. Now notice that this network is going to be learned by AS5 or learned by AS2, and then AS2 in this case will also forward that announcement to its neighbors. So that's how the other networks will learn about AS1, that network. If I need to send traffic there, okay, I need to also have neighbors who knows how to get there. And that is learned by sharing routing information, by forwarding and announcing these routing information. All right. If you don't know how to get to something, to another network, it will be passed on to its default route. So that's an example of different autonomous systems that are interconnected with each other to send and receive um, our, external routing information. Um, let's look at the next one here. Now, when do you actually need an ASN? So we've defined what is an AS, right? So an AS is kind of an independent network on its own. It has its own routing information, it has its peers, it has its own policy. Now you can have an autonomous system number for that AS, but there are some criteria that are involved if you're going to request for your public AS number coming from, let's say, your upstream provider or from APNIC or any RIR or National Internet Registry. So you can see that in RFC 1930, which shows the guidelines for creation, selection, and registration of autonomous system number. The basic criteria or guideline for you to request for an ASN are these two. First of all, you must be multi-homed. What do we mean exactly by multi-home? A network is multi-homing if it has at least two upstreams. An example is a multi-home provider's networks. Okay, it has, let's say, upstream A and upstream B that he subscribed to both of them. Okay, and sending traffic to both of them. So that's multi-homing. Okay, your traffic is going to two different upstream networks. The next one is the routing policy that we have already discussed. The routing policy on your network must be different, must be independent from the routing policy of your external peers. So I guess a good example is if you are an end user customer. So you have upstream providers, right? And then maybe an enterprise network. You have, let's say, upstream A and then upstream B. So that shows your multi-homing. At the same time, you have a set rule in your organization that is unique from your upstream. You're not dependent into your upstream provider's routing policies. You basically have your own routing policy that are set or configured in your border routers. So that's an example. So if you can meet these criteria, then you can request for an autonomous system number. Now, when do we use an ASN? This is an example. I hope that you have an idea about routing because this shows us a bit of routing and how it works. As I've said, when do we exactly use an AS number? It is normally used with BGP, and BGP is an exterior routing protocol. It is used for exchanging routing information. Now, how do you get data? How do you get information? How do you get traffic to come your way? You do that, or that happens, if you announce your IP address. So basically, I have a network. In my network, I have, say, an IP address block. I use that IP address block to assign to my servers, for my routers, and all my end user devices. Now, I am sending, say, maybe for example, for my server, I want this web server to be reachable on the internet. I want traffic to get in there, to get information from there. So how do you make that possible? Now you have to announce your IP address block onto the global routing table. So it goes both ways. If you announce going out, then traffic will come your way. So you notice there is a link here, or a pointer going from AS1 to AS2. AS1 announces to AS2. AS2 must accept that announcement, so it will be added onto his routing table, and then announce it to his other peers. Now for traffic will follow the other way. So packet flow is going this way, right? Whereas routing flow goes the other way. So in this particular example, you have AS1 and AS2 that are networks that are communicating with each other. For them to exchange data or traffic, AS1 must first announce its prefix or its IP address block to AS2. AS2 must then accept it from AS1, okay, and so traffic will go that way. AS2 must also announce its prefix to AS1 so that AS1 knows how to get to AS2, and then AS1 must accept the prefix announcement from AS2. So that's how routing basically works. You announce your IP address block. Normally, the analogy that I give here is when you move to, say, a different place, you have a new address. You want your friends to come over and visit you. What do you need to do? You have to then tell them or inform them about your new address. In a similar way, in routing, it goes like that. You announce going out so that traffic or people will come, or packets will come your way. That's how it works. And we identify these different ASs using our own AS number. So let's look at this. This is the RPSL, or Routing Policy Specification Language. Notice that we have two networks again, AS1 and AS2, connecting to each other. So OTNAM here, AS1, you have to import and export statements. In import statement, you're specifying what prefixes are you going to accept coming from AS2. That's import. Export is the other way around. What prefixes are you now going to announce going to AS2? So in this case, for AS1, we're only accepting AS2, and exporting, we're only announcing our own prefix that we originated going to AS2. So it's a very simple, very basic concept. I have a question there coming from one of the participants. Multi-homing is no longer a requirement to have an ASN. There was a proposal about that. I'm gonna have to double check with you if it's already been implemented right now. But there was a proposal to remove the multi-homing requirement for requesting an AS number. Before you request for that, the best thing to do is double check the policy. It's in the APNIC website, apnic.net/policy, and then you will see the current requirement. Now, for other regions, they may have a different set of rules. So in general, that is the typical rule for requesting an AS number. It has to be multi-homing. Another question there, why do most of the APNIC AS numbers do not have an up-to-date OTNUM or even an ASN? I cannot exactly answer to that because obviously a lot of that will depend on users that are using these prefixes and announcements. Now, what we do is when we create, say when requests are coming in, we make sure that the right information are available for us before objects in the WHOIS database are created. Okay, what else? Any other questions there? Okay, I think they're mostly comments. So I'm just gonna go back and continue with the discussion. If there's anything to add, please feel free to write them down. So this is the basic concept to understand the difference between ASN. Notice here that there is an action preference. It's a value that is preferred over all other routes. So if you set an action preference that is lower than the others, then that will be the preferred route. So you can put different values there, but by default it's set to 100. Another example that you can see here, now this one is a bit more complicated than the previous one. Now for this, we have a bigger network. We have AS123, AS4, AS5, and AS10. Now, a specification says here that AS4 gives transit to AS5 and AS10. So this is AS4. It gives transit to AS5 and AS10. AS4 also gives local routes to AS123. So how do you now put that into an RPSL statement? How do you now define that into a rule? So for this one, notice that this will be the OTNUM object for AS4. Import statements from AS123, which is this one, you're only accepting the prefix that is coming from AS123, something that is originated from AS123. Another one coming from AS5, you only accept its own prefix, and that goes the same with AS10. Okay, only local traffic is allowed coming from them. Now for export statements, we said that for AS123, we are only giving local access, right? So in this case, we are only announcing our own prefix for AS4. We only announce the prefix that we originated, our own AS. We don't have to announce, although we know how to get to AS5 and AS10, we don't exactly announce that going to AS123. Thus, we have this expert statement. Another is for AS5. What do you announce? We said that we're giving transit between AS5 and AS10. So in this case, going to AS5, we also have to announce AS10 going to that, right? So we are announcing AS10. We are also announcing our own, which is AS4. Next one, the last one for AS10, that will have the same rule as AS5. So in this case, we are announcing or exporting to ASN. We announce both AS4 and AS5. So I hope this makes things a bit clearer. When you request for your AS number, you will also have to provide which ones will be your peers, like which networks and their AS numbers am I going to receive traffic, which ones will be my neighbors. And from that, what kinds of policies or agreements do I have with them? Am I only sending them or announcing to them my own prefix? Am I forwarding the rest of my routing table to them? Things like that. So we also have to know about those things. Again, when you request for your AS number, you will have to give or provide, I think, at least two peers that will be added onto your route object. Okay? All right. Now, let's have a look at different ways in which AS numbers are represented. How do we write them down? When you receive an AS number, okay, it is either a 2-byte or 4-byte AS number. Now, in our region, we don't distinguish between AS numbers 2-byte and 4 bytes anymore, but it is good to understand which one falls in which range. The original range of AS number is from 0 to 65535, okay, 0 to 64K. That's your 16-bit AS number. Now, there are other AS numbers in the range. 0 and 65535 are reserved. We don't use it. Now, 1 to 64495, which falls in between or within the range of this 16-bit number, is used for public internet. So I guess you can say that similar with IP address, you can have private and public AS numbers. This range is your public AS number. If you're going to peer with other networks, then you will want to have, or you will have to request for your public AS number. Other ranges include the ones for documentation and sample code, and then this one is for private use, 64512 to 65535. Now, when do you use it? Suppose that you have point-to-point connectivity between yourself and one of your customers. Now, this range doesn't have to be announced to the rest of the internet. It's basically just a point-to-point link between you and one customer. So in that particular scenario, in that particular case, you would normally just use a private AS number. In this case, you don't have to come to APNIC or to a regional internet registry or to your NIR if you have one to request for a public ASN. You can just use any of the private ASNs within this range. Okay, now I'll talk about 2, 3, 4, 5, 6 later on, but that's basically a block that is used for transitioning between or for communications between 2-byte and 4-byte AS number. Now we have extended the ASNs. So similar to IP addressing, you're probably familiar with IPv4 exhaustion. We're kind of in that stage where we don't have enough IPv4 addresses anymore. With AS number, because it's also a limited supply, it's a limited resource, we have kind of reached that point where we think that if we don't do anything about it, we might not have any more AS numbers in the years to come. So to address that issue, then they extended AS numbers from 16 bits to now 32 bits. So as you can see, it's basically just an extension to the original range, which is this. So your 4-byte ASN starts with 65536 up to 2 raised to 32, which is around 4.3 billion. So exactly that's 4294 um, um, million. All right. So that's your range for 4 byte. In some cases, some people would also refer to 32-bit AS number as the entire pool from 0 all the way to 4.3 billion. Okay, it's the same thing. That's basically just the extended portion of your 16-bit ASNs. Now, what about the other ranges? From now within that block, you also have blocks for documentation, two blocks that are reserved. You also have a block that is used for public internet, a public AS number, and ones that are used for private. Now, if you come to APNIC and request for your AS number, you would, as I've said, there is no distinction between public and, there's no distinction between 16 bits and 32-bit ASN, or 2 byte versus 4 byte AS number. You would be given from that entire pool. Normally, it will be within the 32-bit range, most likely. Now, if your devices do not have support for 32-bit ASN yet, then you must specify on your request that I need 2 byte ASN because basically my router does not have support for 4 byte AS numbers yet. That's how you did, but by default, there is no distinction between them when you get it. All right. Now, there are two ways to write an AS number. In our region, we just write it plain and simple with RFC 5396. That's called AS plain. It's essentially a continuation, as I've shown you in the table from the previous slide. It is only a continuation of a 2-byte AS number. So it's basically, if you reference it or represent it in decimal, that's AS coming from 0 all the way to 4.3 billion, right? So 0 to 65535 for your 2-byte, 65536 to around 4.3 for your 4-byte. As I've said, in our region, this is what we do. There is another way to represent it though. It's called AS dot. Now, for some people, this is easier because essentially you're kind of still using the 16-bit range. So for your 32-bit range, you subdivide it into two and then separate them with a dot. So that's why we call it as an AS dot. So your first half, which is your higher bits, and then your second half, which is your lower bits. And from that, you convert those binary digits into decimal. So at the most, you can have 65535.65535. Okay. There are other RIRs, especially in the US before, that are using AS dot. I have to recheck now if they are mostly using AS plain and AS dot. But yes, there is more, I think, more inclination for operators to use AS plain over AS dot. And that is mainly because of the limitations that you get with AS dot. Specifically, if you have a lot of, say, rules or ACLs, or if you're using regular expressions to get your different matches, then it will have some application. If you're, let's say, moving from 16-bit to 32-bit, then you might need to have or change some of your configuration if you're using AS dot. Whereas if you're using AS plain, it's kind of, I guess, an easier way of migration of your configuration compared to AS dot. But yeah, some people would prefer this. In our region specifically, we normally just use the AS plain configuration or AS plain representation. Okay. If you look at this one, this is an example just to show you how it is converted from one to the other. AS plain, if you have 131072, that's equivalent to 2.0, and that's because that's twice of 65535. So if you're going to convert going from AS plain to AS dot and vice versa, and you're working with decimals, of course you can find converters that are available on the internet. But if you look at it and do simple multiplication or mathematical functions there, you can easily find that out by dividing it or subtracting it from 65535. So you can try this on your own, try this at home, to convert from AS plane, which is 131.072, then you should get 2.0, and then 132.095, you should get 2.1023. All right, so just give it a try. But those two things are how you represent an AS number. Now, the problem here is, what do I do if one of the networks that I'm peering with is using 32-bit, and my network or another network that I'm connecting with is using 16 bits? Now, there is obviously a discrepancy between that, because with 16-bit, if you're running 16-bit, you don't know or you don't understand the 32-bit ASN. Now, how do we still exchange information, routing information in between them? How does your route entry look like, or AS path would look like? So we will use a special number. This special number is called AS23456. It looks quite funny. You look at it first. If you don't understand what you're looking at, and if you see the routing table, you look at the AS path and you see different values, and then there's one or two that says 23456. So it's actually used for this purpose. It's the way in which your 16-bit or 2-byte AS numbers can still work along 32-bit ASNs. Again, that's because 16-bit don't have an idea or do not understand 32 bits. So when you receive prefix or announcements that has a route that goes through an ASN that is like more than the 16-bit range, then it is represented as AS23456. So again, anything that is in your 32-bit ASN, when you look at it from a router that only understands 16-bit, you will see AS23456. This is the solution that they come up with that allows BGP to truncate the AS number if they detected an older version or a 16-bit ASNs in the network. So this means that even if you're running, say, if you're still using 16-bit ASN, there really is no, well, you're not getting, you're not at a disadvantage if you use a 16-bit ASN over 32-bit ASN. If your routers don't support 32 bits, then it's fine to still keep using your 2-byte ASN. The only, I think, it's not exactly a problem, but the only thing that would be different for you is you don't exactly see the exact path. If you have a lot of 32-bit ASNs, you all see them as AS23456 in your AS path. All right. But other than that, if you're running if you're okay with that, if you're running or if you're using 16-bit ASN for a particular network, then it's fine to continue using it. But for newer networks or new deployments perhaps, or new peerings, then if you request for an ASN for that, you will get a 32-bit ASN. So this is some of the eligibility requirements which we have kind of already discussed, but the request process is very easy. If you're already an APNIC member, then it should be straightforward. Log into your My APNIC account, go to the resources tab, and then request for more resources, and then provide information about your ASN request. Again, as I've said, you need to provide at least 2 peers should have information about those things before you apply for that. Make sure that it is already ready for you to use when you're asked to provide for that. Now, if you're a new member, if you're not an APNIC member yet, you can also request for your AS number at the same time with your request for membership. Again, membership is required for any resource request, whether it's IP or AS number. So before you request for that, you will have to apply for membership. But the good thing is you can apply for both membership and a resource request at the same time. Now, particularly with AS number, you can do that. Now, if you are, say, you're not an APNIC member, but you have ISPs, you have upstream providers, you can also, your upstream provider can also request in your behalf. So if you're an ISP, you can request for your customer, okay, come to APNIC and request in behalf of your customer. The thing there is, similar with IP address, there is such a thing as portable and non-portable AS number. With portable AS number, it's usually given to APNIC members, right? With portable, we mean that you can use it at any point in time, even if you change upstream providers. Whereas with non-portable AS number, that means that you are now going to, let's say your ISP is going to request on your behalf. And so if you are moving from one ISP to another, you have to return that AS number to the upstream provider, to your ISP, and your ISP must also return that to the ASN pool because no one is using it anymore. Then you as a customer, for new upstream provider, you have to request for a new AS number. All right, so I hope that's clear enough. That's how you go about with the request process. Now I've seen a few activities in the chat. I just finished my talk there before I go to the chat and try to answer them. A few questions there. Which ones have I not answered? Can you say if other RIRs? Yes, we've already answered that one, right? Is there a market overview? How many routers are capable of 4-byte ASNs? I'm pretty sure there is. I'm not familiar with them. If you're running newer firmwares, newer iOS and things like that, it should have 4-byte capability. If you're running legacy routers, then you obviously probably wouldn't. But I haven't seen any market overview that gives you, let's say, a graph or statistics that relates to that. Sorry about that. Another question is the Prop 114, which is in the mailing list, saying that they removed the multi-homing requirement in the next meeting this year. Yes, that was in the proposal. If you attended or if you have a look in the last meeting, it was a proposal to have it removed. I can't remember exactly if it has already been approved. I think it is, but implementation-wise, it takes about a few weeks before implementation. Generally, after the meeting, once a proposal has been agreed upon, it reached the consensus, it will still come back to the mailing list for another 4 to 8 weeks and then see if there's consensus in the mailing list before it will be endorsed. So from the last meeting to now, then it's still, again, I think it's still in the mailing list for further checking or consideration from the rest of the community. So yes, if it gets approved, if it gets consensus in that process, then in about 3 months it will be implemented and you will notice or you will see that removed in the current policy. But if you check the current policy now, I think it's still there. So yeah, but yes, the proposal is there and I think it reached a good outcome in the last meeting. All right, so for everyone else, just a side note that that's the APNIC policy development process. And I've shown you some of the eligibility criteria when you're requesting for this particular one, it's AS number, but it's also the same with, let's say, IP address. And if you notice that the eligibility requirements that we are discussing is not something that applies to you, then you are free to suggest a proposal, and that goes through the policy development process. That's what Hamburger is mentioning about here. The requirements that we have, the eligibility requirements for AS number, okay, is discussed during the last policy meeting. All right. So yeah, if you want, you can try to be active in that front as well. If you're not, if you see that the requirements do not fit your current, say, situation or your networks. All right. I've answered all the questions, right? Any others? How about the other two participants? Let's try to make this interactive. So if you have questions or comments like Hamburger, please feel free to comment it out. Okay, next ones we've already discussed about portable and non-portable. So just to review, portable ASN is something that members would get because these members will be responsible for registration for that. They get that as a portable address because it's taken from the APNIC pool, from the RIR. If you are a non-member or if you get your AS number from your upstream provider, then it is considered as non-portable. You must meet the current criteria, okay? And the member will be responsible for registration here, and then if it's not used anymore, it has to be returned back to the pool. That's how it is. This is just like a run through of the dates when we started using or not using, but like providing or delegating 2 byte and 4 byte ASN. So in 2007, by default, we were still giving 2 bytes, but we started giving out 4 bytes as requested. In 2009, say, it switched. It became 4 byte. 4 byte is now the default. Now in 2009, 4 byte is the default, and 2 byte processes are only given or provided if they can show, they can justify that they actually need 2 byte over 4 byte ASN. And as of 2010, right now, as I've said, there is no distinction between 2 byte and 4 byte AS number delegation. Okay. Yes, definitely. Um, Portable versus non-portable is only relevant if you want to move your business to another RIR region, or what is the difference between? It's not exactly just different regions. Essentially, if it depends if you're a member or not. If you are an APNIC member, then you would get a portable ASN. Basically, anything that's coming from RIR are portable. But anything that's coming from an upstream provider, an ISP, are non-portable. So if you're an end user, say an enterprise organization, and you get your AS number from your upstream provider, it only goes to show that there is an intrinsic agreement there between you and your provider, that you get that because, of course, you are subscribed to them and they requested that is number to RIR, to APNIC in your behalf. Now, if you're no longer using the services of your ISP, you want to move to another ISP. I guess it doesn't matter whether it's like just within the region or not, but as soon as you move to another ISP, you have to return back the AS number that you currently are holding, okay, to your upstream. Your upstream provider will again return that to the current available pool. Now we go to your next provider and then request for an AS number from them. It's very similar to how non-portable IP addresses work. Say if you get an IP address and if you move providers, you have to give back your IP address and request for another block from your new ISP. That's how it works. Does that answer your question? Okay. All right. Any other questions, guys? Now, we're just about, I think, winding down here. We also have transfers of ASNs. So you can transfer autonomous system numbers within the APNIC region. It is also now possible to do that between regions, given that there is a policy in the other region that you are going to transfer it to or receiving it from. In our region, we have that policy in place, but if you're, say, exchanging or transferring from your network or from your business to another business that it's in Europe, so our not our RIPE NCC should have a similar policy for ASN transfers before you can proceed with this transaction. Okay? Yes, I don't think it's possible to do that yet with RIPE. I'll have to check if it's possible with Aaron, but there were proposals with the other regions to make that possible. So I guess if you really need to do that, then you have to wait until they have that kind of policy. Okay, now continuing on, here is an example of an autumn object. So an autumn object is an object in the WHOIS database. The WHOIS database is an open database of all resources, okay? Number resources. Relates to domain objects. It can have IP or netnum or inet6num objects. And another one which is particular for AS number is the autumn object, okay? Autumn object, see here, you'll see the one that's given to you, and then the name and description for that. And the important part that I really want to show you is the one highlighted. That's your import and export statement. Now, you shouldn't be surprised. You should be familiar with this by now, right? So notice that in this particular example, they provided 3 pairs. So AS4777 is my AS number. I am pairing with AS2500. I'm also pairing with 2524 and 2514. Notice that I have a very simple policy with regards to this. I'm accepting all the prefixes that are announced to me by these providers, okay, by these peers. There is another one for export statement. Export statement, I'm pairing with them, I'm announcing prefixes to them, but in this case, I'm only announcing my own prefix. I'm only announcing AS4777. So you notice that those are representations of your own policy. You can also have defaults. So in this case, defaults to AS2500, or my basically most likely that is my main upstream provider where my commodity traffic would go. So in that case, going to AS2500, I'm allowing everything or allowing any. All right. So that's your RPSL statement over there. You have other information there, administrative and technical contact. Make sure that this one is always updated. Okay, some information or notes about this current prefix or this current AS number, and information about changes that have happened and where to find these sources. Do you have a specific training to learn about RPSL or modify autumn or AS set object? Well, unfortunately, I don't think we have something that's only specific to that. If you want more information about RPSL, we have routing sessions that pretty much discusses a little bit like this, just in more detail. With autumn and AS set, I don't think we have one that focuses on AS set. With autumn object, aside from this, it is also discussed in the WHOIS database presentation or module. So try to look at that. But if you have any particular question though, specifically about AS set, and this is very useful if you are managing, say, a huge network that has a lot of peers, so you can set up your own AS set. What you can do is maybe, if you have particular questions, maybe check with our help desk team on how to do that for your how to create these objects for you in the WHOIS database. But yeah, but only specifically RPSL, we don't. This is like one of them, and the other is routing. So I hope that's okay. But you can send us email, training@apnic.net at any time if you want to learn more about it, or if you have any particular questions that you want technical answers to. So we can help you with that too. All right? Okay, anything else? Any other questions from the class? Okay, this is the graph of the distribution of AS numbers within different regions. APNIC is yellow, so you see there, we're about here. RIPE NCC has got the most. I think we're getting higher numbers, I think, this year, so hopefully we'll have good statistics the next quarter that we come up with this graph. All right, this is, by the way, from quarter 3 of 2014, published by the Number Resource Organization, or NRO. And that's basically it. Any other questions? Everyone in the class? No? I think we had a really good discussion here. Thank you very much for all your questions and comments. I really like that it became interactive, and with that, I guess all other participants have also learned some extra things that they probably wouldn't know if those questions were not raised. So thank you very much for that. But if there are any more questions from the class, please let us know. If not, I'm actually going to just put the link to the survey on the chat window. So after this, if you can spare a few minutes to fill in the survey, you may just take a couple of minutes to finish it up. Please do that for me. Another one, if you want to have a copy of the slides, it is available here on this FTP link. So please download the PDF copy so you can review it later on. All right, so with that, thank you very much, everybody. Thank you, all three of you, for attending this session. I hope that it has been helpful to you. And again, if you have any further questions, we're here to help clarify those things for you. So please do send us an email, and hopefully you can also join us in another e-learning session in the future. Thanks again, everyone, and bye-bye.